Hello friends, in the last video we have studied, in the last previous two videos and all, we have studied the concept of derivatives. What exactly does derivatives mean? Very briefly, of course, the geometrical aspect as well as the physical significance. And then we have seen how do we differentiate using just a direct method. Now this is one method with which we can also differentiate. To differentiate by the delta method, it is called, or it is called ab-initio method, or it is called by definition method, or is also known as to differentiate by the first principle method. So all of these methods just mean the same concept, same method. Okay. Now this is more of a a traditional method which is more based on the explanation of the topics that explanation of the concepts of derivatives which I discussed with you, the geometrical approach. Now, of course, as per the definition, if it goes like if y is a continuous function, that is, if there is no break in the graph, continuous function of x and delta y, delta y, okay, delta y, the increment, that small increase or small decrease, increment, small increment in y corresponding to a small increment in delta x in x, then the limiting value, this will all come into connection, because if you haven't watched the previous video, the concept of derivatives, please go back and watch, especially here for this, the geometrical part about that graph, the tangent, how can we draw the tangent when the points are very close to each other, isn't it? So the limiting value of delta y upon delta x, as delta x tends to 0, that is, as it gets closer, we are able to draw a tangent passing through 2 points, isn't it? Then if it exists, yes, only when we can have a tangent, is called the differential coefficient. Most of us, we really do not know some of the basic terms, so I've given you the full concept here. Please take out your pen and paper, and I'm going to discuss on how to differentiate also using this method. Differential coefficient of y with respect to x denoted by dy by dx, that is also known as derivative of y with respect to x. Okay. Alright, so now it's actually, you will understand the concept, because see, I'll just briefly give you the concept. That was like, if this was a graph and then you were told when is it possible to draw a tangent passing through 2 points, then we have discussed that it is possible for us to draw a tangent between these 2 points only when the distance between these 2 points is very close, only when this increment, which we denoted by 0, is like approximately very equal to 0. That is, only when the space between a and b is very close to each other, very small, then only we can draw a tangent. If we can draw a tangent, then yes, the derivative exists. So it's based on that concept only. So I'll tell you more about when I give you the formula. So now I want you to pick up your pen and paper and then start writing down. I'm going to give you the steps on how to differentiate or to find out the differential coefficient using this method, that is by delta method, or by ab-initio method, by definition method, or by the first principle method. Okay. Alright, so you can write down, you can start, that is guidelines to find differential coefficients. Okay, guidelines to find differential coefficient. Number 1, the first step. Okay, you can write down, I'll just dictate, please write down guidelines. Okay, guidelines to find differential coefficient. Guidelines, I repeat again, guidelines to find differential coefficient. Are you done? Okay, first step, that is step 1. Let y equal to f of x. Let y be the function, always. Let y equal to f of x. Okay, be the given function. That is going to be equation 1. The next step. Alright, the next step that you're going to do is let delta x, okay, let delta x be an increment in x, be an increment in x, and delta y be an increment in y, So therefore, what will happen is, if y is given a small increment, then if y is given a small increment, then it also means the function will also be given a small increment with respect to in x. Okay, all right. So that means if we have the graph, if x is increased by a little, if this was the graph, if x is increased by a little, then what happens? Y will also be increased by a little. All right. Okay. Once that is done, step 3. Step 3. Okay. So this can be your second equation. This can be your second equation. Okay. Now step 3. What you will do is subtracting 1 from 2. This will be the steps, okay? This will all be the steps that you will be following. Subtracting 1 from equation 2. Subtracting equation 1 from equation 2. So if we subtract equation 1 from 2, what you will have is, okay, let me just subtract. When you do the solutions, you can directly do, that is f of x plus delta x minus f of x. So y, so delta y will be f of x plus delta x minus f of x. Okay, so this is going to be your third step. I'm going to rub the other steps. Now step number 4. Step number 4. What I will do now is dividing both sides by delta x. Next step, what you will do is divide both sides by delta x. So you will have delta y upon delta x. That's going to be equal to f of x plus delta x. What's that? Delta x represents a small increment upon delta x. This is going to be your fourth step. This is a very simple procedure. Please follow the steps. Alright, that's why I'm telling you to write it down, because it's going to be very important. The next step, what I will be doing is I will be taking limits on both sides such that delta x tends to 0. So taking limits on both sides such that delta x tends to 0. No, delta x tends to 0 means what again? As long as the points are very close to each other, as they approach each other, as the 2 points approach each other, we are able to draw a tangent. Right? Please go through that previous video. So limiting value as delta x tends to 0, f of x plus delta x minus f of x upon delta x. Alright, okay, so that would be your step 5, and thus, alright, finally, thus dy by dx, the derivative of the function y with respect to x, is nothing but the limiting value of this value, delta, as delta y by delta x, okay, this one delta x, which is equal to limiting value as delta x tends to 0, f of x plus delta x minus f of x upon delta x, if it exists. If it exists, that is, if the right hand derivative and the left hand derivatives are equal, alright, which is also equal to f dash of x, that we already discussed in the previous video, which is derivative can also be represented as f dash of x. So this will be the steps that you will be following if you have to differentiate, or if you have to find out the differential coefficient. Alright, if you have to find the differential coefficient. So in the just in that first part I had written how to find out the differential coefficient. So the process of finding out the differential coefficient is called actually differentiation. Okay, the process of finding out the differential coefficient of a function is actually called of course differentiation. All right, okay, so let's continue. Let's try to solve one example. So let's try to solve maybe one question. So to differentiate by delta method, okay, let's solve this one example, that is, if the function is given to be like 10x, if the function is given to be 10x. So let's try to solve this question. So now we know what is the derivative of 10x. If we just use the direct method, derivative of 10x, what will it be? It's going to be 10. So our answer should be also 10 again, even if we use the delta method. Okay, so let's try. So what do we have? Let y equal to f of x. So what is our f of x here? Let y equal to f of x. That is what? Y equal to 10x. Alright. So now step 2. What was step 2? What was step 2? We will add a small increment, that is y plus delta y. So that will be what? 10 on x. We will be putting a small increment, that is 10x plus delta x. Alright? Isn't it? Because you see, because my function is how much? 10x. So f of x plus delta x will be equal to what? 10x plus delta x. Okay, don't be confused there. So this is my equation 1 and this is my equation 2. So after that, the next step, what do? Equation 2 and 1 we subtract. So y plus delta y minus y equal to 10 of x plus delta x minus 10x. So y we have delta y is equal to, I'll just multiply 10x plus 10 into delta x minus 10x. So delta y equal to 10 into delta x. Right. So next step, what do? So next step, what do is we divide by delta x. So 10 delta x upon delta x. So now here delta x cancels. So delta y upon delta x equal to how much? 10. Of course, this is still not the answer. We still have to finish the procedure yet. So now, what do? Limiting value as delta x tends to 0. Delta y upon delta x will be equal to same limiting value as delta x tends to 0, 10. So this is what? Dy by dx, derivative of y with respect to x, and that's going to be 10 because delta x we don't have here, we have a constant value 10. So as expected, what do we have here? Our answer that we get here is how much? 10. Alright, so that is what we were supposed to find out. Okay, so this is the procedure on how to use this ab-initio method that we call it. Okay, so let's try another question. Maybe just one more question that we can try here, that is we can try one question, not many questions. Okay, let's try this question then, number 1. And number 2, that is y equal to x plus 5 upon power 7. X plus 5 upon power 7. Alright, so as usual, I'll just start straight away, that is equation 1. So now next, I will add an increment delta y. So on x, with x, so x will change with, that means if x is 4, a small increment 0.1, so x will be 4 plus 0.1, 4 plus 0.1. So x value will increase, y value also increase with that small increment. So now what happens? This becomes equation number 2. So next, what do? Equation 2 minus equation 1. So I will not write here, already done before. So delta y equal to, so this will become x plus delta x plus 5 whole power 7 minus x plus 5 whole power 7. Alright, so now I will divide. Okay, let me do stepwise. Next step is, nothing can be done here, so I'll divide by delta x. So that's going to be x plus delta x plus 5 minus x plus 5 whole power 7 delta x. Alright, so these are the steps that we will have to do. So now next step, what shall we do here? Next step is, this will be the next step. Okay, I will just write upon this. So what will be our next step? Next step will be what? Limiting value as delta x tends to 0. Delta y upon delta x will be equal to, again, limiting value as delta x tends to 0. This is that next step. Okay, now If you remember, there was a formula for limiting value of x power n minus a power n upon x minus a as x tends to a. What was it? N into a power n minus 1. Almost same. This is x, this is a. We have here dx. So what can we do here? If we can add and subtract, I think there will not be a problem. If we can add x and subtract x, add 5 and subtract 5, then it will be almost similar to this, you see. So if this exists, so this will be derivative of y with respect to x now, right? So limiting value as delta x tends to 0. Of course that will change, but let's see. So that will be, this will remain same, plus 5 upon 7 minus x plus 5 upon 7. Now if we use bracket, this will be x plus delta x plus 5 minus x plus 5. Now you see that the formula almost is matching perfectly, isn't it? No? What was the formula? I write again as x tends to a, x power n minus a power n upon x minus a, n into a power n minus 1. So you see here, this is x, right? And this is y. But of course x tends to a, so definitely it will change, because what happens is x plus, so if delta x tends to 0, what will happen? X plus 5. If I add x plus 5, this will also change to x plus 5, isn't it? Because delta x is almost tending to 0. So if I add x plus 5 to delta x, so it will be like 0 plus x plus 5. So that will also tend towards x plus 5 only. So here I can make a small arrangement, that is x plus 5 plus delta x tends to x plus 5. Okay, you just write it properly. Alright. Okay, I'll just arrange a little bit more again. That is limiting value x plus 5 plus delta x tends to x plus 5. This is actually derivative, that is dy by dx. Understood, isn't it? Because we had as x, delta x tends to 0. What happens if I add x plus 5? See, if x is approaching 0, if x tends to 0, I add 5, x plus 5. So if x tends to 0, x plus 5 will tend to 5, isn't it? 5 is added, right? So now I can apply the formula. I think this is done. You can just write this in the rough or in the side of your solution. Important, okay, necessary. So now I can apply the formula. What was the formula? That is n. That is n is 7 into a. What is a? This. N into a power n minus 1 as per the limit formula. So 7 into x plus 5 whole power 6. So if you differentiate using chain rule, you will get the same solution, that is x plus 5 whole power 6. Alright, so that's the way we use this first principle method. So there are many problems in the exercise. So in the next video, what we will do is we will try to solve the exercise problems given in the exercise using this first principle method or ab-initio method or delta method, whatever we call it. Alright, so if it is not very clear to you, don't worry. In the next video, we will be solving more problems. So stay tuned. Please watch the videos to the full, and don't forget to subscribe and to like, and of course share it with people if you have learned from this video. Alright, so thank you so much. I'll see you in the next video where we will be solving more problems on this delta method. Alright, bye bye. Till then, take care.